All right. Okay, let's get going. So, welcome everyone to tonight's virtual meetup. We're going to be covering Presto meets Elasticsearch um, with Itamar from BigData Boutique presenting. And so the agenda will be, we have some announcements. We'll talk about the Elasticsearch overview, and then we'll get into the main event of Presto meets Elasticsearch. Definitely share where you're from, throw in questions into the Zoom chat. If you haven't already, please scan the barcode. I'm going to track where people are coming from. Also, we have Phoebe Quincy from the Elastic community team, and she'll be reviewing questions as they do come in. And a little bit about me. I am not an Elastic employee. I'm actually a VP of Tech Ops at a company called Edlio. Edlio's in the ad tech industry. We do websites, payments, and engagement systems for 12 through K through 12 schools, and we have about 15,000 schools worldwide, mostly in the United States. I've been using Elastic Stack since version 1. Ran a production environment for over 6 years. Observability has been the primary use case, and really, enabling the developer teams to be able to create their own custom logs. And we had over 30 application logs at my biggest implementation, multi AWS regions and one cluster. And I've been contributing to Elastic community for over the last 5 years. I've been Elastic LA organizer for the last 5 years. I've spoken at a couple conferences, the ElasticON 2018 and also Scale 16. And I've been a 2-time Elasticsearch Cause awards judge, which allows companies and individuals to present their architectures across a number of different categories, but it's an opportunity to really promote what you're doing if you're doing some really cool things with Elastic. All right. And then for announcements, I'm going to hand this over to Phoebe, and she can take it from here.
Yeah, just coming up around the corner, October 13th and 15th, we are holding our massive virtual and free Elasticon Global. If you're familiar with Elasticon in the past, this was a ticketed event, and we're happy to say that now that we're moving to a virtual world, that everything is getting easier. And so this is free. There's over 100 events that are going to be happening here, and there will more than 50 sessions. We've got 100 now sessions, and there will be some really awesome speakers there. So definitely check it out. And then the Elastic Contributor Program is a new program that the community team has rolled out, where we are trying to help highlight those individuals who are contributing to our community through either code revisions or speaking engagements, blogs, organizing meetups like Rich does. And it's kind of a friendly way to, sort of get folks invested in doing more. So if you go to the next slide, these are some of the prizes and awards that go with our contributor program. And as you can see, there's different levels. And when you go to the website for the contributor program, you'll be able to look at this more in depth if you want to go to the next slide, Rich. Basically, yeah, event organization, presentations, written content, video tutorials, translations. This is a key one, as Elastic is a global company and we have user groups all across the world. The need for translating some of our workshops or demos is really valuable. So we look for the community to help us out with that. Code and contribution validation. So when you submit a contribution to this, your peers will validate you. So we want you to engage and validate your peers as well. And I think that's it for the contributor program. We do have a Slack workspace available where you can chat with Elastic community team members and as well as folks in the community. And there are different channels within this workspace for all of our sort of solutions and tools. And you just grab that with a QR code reader and it'll take you on over to that. Free and open for everyone. And I think that might be it, Rich.
Okay. And then for the virtual meetups, my goal is to hold a meetup the third Wednesday of every month. And now we have another meetup coming up on the 21st, and I actually got a speaker who's going to talk about Fleet and the Elastic Agent. And I'm still looking for speakers for November 18th and December 9th. And you can see definitely for the holidays, I did change the schedule around a little bit, but definitely ping me. Let me know if if you want to present any topic at all, anything Elastic Stack. I'd be happy to we can talk about that. Let me do a quick overview of Elastic Stack. So, at the end of the day, search is the constant foundation for what we're doing. Whether we're looking through a whole bunch of records, whether we're trending it, whether we're doing maps, everything is what we're looking at is around search. And based off what you're doing, these are some of the companies, and these are all the different things we could be searching for: bugs, fraud, tickets, movies, uptime. It really goes the gamut for what you can be searching for. And what I like is recently in this year, Elastic has really fine-tuned their how they position things. It's really around search, observe, and then also protect. And this really breaks down into the 3 solution categories. So we have Elastic Enterprise Search for site search, app search, and also workplace search. Workplace search is one of the newer ones where you can actually go beyond. You can search Jira tickets. You can talk to Google Drive, Gmail. It's really connecting all the APIs that are out there and pulling that data into Elasticsearch. And Elastic Observability, to me, this has always been my main use case, as I mentioned before. But you also have APM, you have logs, and you have metrics. And then security, you have the SIEM and also the endpoint security around that. So basically, the 3 solutions still powered by one stack. And when you look at the stack, it's really, you have your ingest layer where you have beats and Logstash where it will push the logs into Elasticsearch. Elasticsearch will store it so we can analyze it and search the data. And Kibana is the visualization and management. And especially over the last couple of years, Kibana has been more and more that management and that window into Elastic Stack. Pretty much Elasticsearch has always been rich where it's come to APIs. Now Kibana is really just building the front end so you can utilize those APIs through a GUI. And typically, this is a typical configuration for Elastic Stack overall, where you, like I mentioned, you have beats and Logstash pushing into Elasticsearch, and then you have Kibana on the front end for the visualization. So you have your ingest here, and then you get your storage in Elasticsearch, and then you get your visualization and management. So let's talk about Elastic Resources. Elastic.co, the website, all the time, almost every other day, there's a new blog post, a great source for to dive into. What I really like is since version 7.8, they've actually have each of the versions listed now, so you actually can go in and really go see what's new across the platform. And also what I like about Kibana, now they actually, they describe the feature, but they're also giving the visualization of what it is. And there's a lot of these have GIFs, so you can actually see what the feature really is. And this is, like I said, since 7.8, at least I've noticed it. It's really nice. Helps you really be able to look at things immediately and see what's happening. And also for external links, we have the newsletter. Sign up for the community, get the newsletter, you keep up on things. Latest releases, you also will get notifications on webinars. Also, the webinars are also on their site. Also, there's a new community YouTube channel. Discuss.elastic.co is a very vibrant forum. Thousands of questions. You can post your things there. Also, if you want immediate and really interact quickly, you can also join the Slack community that Phoebe mentioned earlier. And like I mentioned, the YouTube channel. And then also there is some level of free Elastic training. So take advantage of that. If you're not as familiar with the stack, you can definitely get some high level views into that through the training. And also, give a talk. The best way to learn is to teach. And if you're interested, let me know. I'm always looking for speakers. So with that, I'm going to hand this over to Itamar. I'm going to stop sharing.
Hi, everyone. Good evening. Let me just share my screen.
It's all yours.
Yeah, thank you. Thank you, Rich, for having me,
Yeah.
Phoebe too. So what we'll do today, we'll talk a bit about Presto and Elasticsearch. I don't know if I can do a poll over here, but if there is a way to raise hands or something, can you guys just raise a hand or mark yes, no, if you've had experience with or heard about Presto before? Rich, can you help me? Do you know if there is a way to see that?
I think if everyone can just type in the chat would be the easiest way. I don't think we have that. So I've heard of it
just
before.
So I get a feeling of the experience in the room.
And make sure you have your chat on panels and attendees so you can show it.
Yeah. Or it's just some experience or some past experience with Presto, either directly, apparently, or using Athena. So that's cool. I'll start with a short intro about what Presto is and how we currently use it and who we are and who I am. And then we'll switch to actually talking about the combination of Elastic and Presto. So my name is Itamar. I'm the CTO and founder of BigData Boutique. I've actually been using Elasticsearch for the past 8+ years. So I'm a user since version 0.12. And I've been consulting and helping companies and organizations grow their data platforms essentially, and specifically Elasticsearch for the better part of the last 8 years. I currently lead the company, lead the team in the company, and we do a lot of work in the big data and in big data space and data platforms. And our bread and butter is really Elasticsearch, and we help many organizations worldwide with that. So I actually spoke in the LA meetup a couple of years back. I think it was like 5 years ago or something like that. So when it was really, I guess, sort of beginning physically, back when the world was normal. And I've been working with Elasticsearch ever since, doing a lot of things, and now starting to really combine a lot of things with Elasticsearch. And that is what we're going to talk about today. So this is us. Again, we build and maintain and optimize data platforms in general. Sometimes it's big data, really. Sometimes it's just big data is just a buzzword. And Elasticsearch a lot of times has a lot of roles in there. So it could be used for monitoring. It could be used for keeping data that is considered hot and needs to be have very low latencies. And sometimes Elasticsearch is just a piece in a whole puzzle. And that is what we're going to talk about today. Our team is probably one of the best consulting teams in the world in terms of Elasticsearch. We do, like I said, we do training, we do a lot of work in consulting, hands-on consulting, hands-on development, performance and cost optimizations, data modeling, and we also have Elastic certified engineers in the team, and we are very confident in what we know, what we do with Elastic, and feel free to reach out if you need our eyes or hands on anything. So Presto, we do a lot of Presto as well. Ever since it was released to the open source, and we started working with it and implementing it in various data platforms for our customers. Presto was the inception of Presto was about 8 years ago in Facebook. So Facebook have obviously a lot of data, and many analysts and many other people who are interested in that data. and they wanted to make data more accessible. So back in the day, in the Hadoop world, so in the Hadoop world, you wanted to give access to data, and you would write a Spark job or a Hive or SQL commands and pass them through Hive. But that wasn't really interactive in any way, right? That Hive SQL, Hive would have compiled SQL to some sort of a MapReduce job. Later on, it became other things, but essentially it was not real-time or interactive in any way. And it also only allowed you to interact with data on HDFS and things like that. So Facebook wanted to try and solve that, and an engineering team within Facebook wanted to try and solve that challenge. So they wanted to provide faster queries, more interactive way to interact with the data, do this in a cost-efficient manner, and also make sure that you can access various data sources, even apparently in a single SQL statement. So fast forward 8 years, we have Presto as a full-blown open source project being used by small companies like Netflix and Comcast and FINRA and NASDAQ, and you have many of those names over here. There's plenty of others. And we have partnered up with Starburst Data, which is today the home. So since yesterday, actually, it's the home for all 4 Presto founders in Facebook. And that's the commercial entity behind the open source project Presto. And those names that you see on the right are basically just adding more and more and more. And Presto's goal is to make data much more accessible. It is often referred to as an MPP, so massively parallel processor for data. So it does not host or it doesn't store any of your data. It is just a way for you to get access to your data using queries. Then the query engine accepts SQL queries. So it allows you to connect from pretty much anywhere to submit your queries. And it is then able to basically be some sort of a proxy between you and all of your data sources. And by data sources, I mean, of course, S3 and Hadoop and those file storages, what I often call as cold storages. And that is traditionally what Presto was built to do as a replacement for Hive. So you have terabytes, petabytes, even more scale of data, and you store that in files on S3, on Hadoop, those file systems. You need to know how to do that correctly, but it's not too hard to learn. But once you do that, that data becomes accessible and very, very easily queryable. So that is what Presto was built to do from day one, and it still does today. And of course, also any SQL databases as well. So MySQL, SQL Server, Oracle, and so on. So obviously, if there is a SQL database, Presto can also connect to that, and that's a no-brainer because Presto, like I said, speaks in SQL. However, Presto, surprisingly or not, can also talk with data stores that are not relational in any way. For example, things like Cassandra, Redis, MongoDB, Kudu, and of course also Elasticsearch, which is the reason why we are all here today. Presto would basically translate the concepts of those data stores. So Cassandra is key values, and MongoDB, very similarly to Elasticsearch, deals with documents, and Redis is again key value store, and Elasticsearch is its indexes and documents. So Presto will somehow translate in some way the concepts that those data stores expose and make that into tables and rows and columns, exactly what you would expect to see in a SQL database. And the piece of code that is in charge of doing that is what we call a connector. So a connector will take the query or the query parts that are submitted to Presto and will somehow execute that on those underlying storages. And I'll talk about a bit more about that in just a second. And if you're making this in a smart way, if that connector is smart enough, it can also take things that are completely not, let's call this, you know, even remotely close to what the SQL resembles, and also allow you to query that with SQL. And for example, Kafka is a good example to that. So the Kafka connector can actually allow you to query Kafka with SQL. So there is already such a thing, right, in KSQL and Kafka streams, but Presto can do that as well. So there's plenty more connectors, but the idea is that Presto can allow you to connect to many types of data sources. And the way you connect to Presto is just using a simple JDBC and ODBC drivers. So pretty much any technology, any querying technology can be used to use that. So it could be Redash and Superset and Zeppelin to let you just type in SQL statements and get back the data sets and maybe visualize them. You can use commercial software like Tableau and Power BI and many others. Just BI tools that will be able to communicate with Presto, query Presto, query the data sources, or really take a lot of data in, Jupyter notebooks, and pretty much any SQL IDE like DataGrip or dbeaver or you name it. So any querying tool that supports ODBC or JDBC can just talk to Presto. So once you go with standards, you basically get a way to connect with pretty much anything. So that is Presto in a nutshell, right? So you have a way to basically take queries and push them down into the data sources, get data back from the data sources, and communicate that and expose that to pretty much any querying software. So there is a question here: are there different distros for Presto or just one official one? So the history goes like this: Facebook built and released Presto, like I said, about 8 years ago, and it was released to open source shortly after, and that is what we often call Presto DB. It's not really a database, but this is what it was called. A couple of years after, the people that built Presto, so Martin, Dave, and Dane and Eric, so the four people who built Presto, you know, that happens, left Facebook and continued supporting and developing Presto from outside of Facebook. And then due to some various disagreements about the direction to the project was going, they just forked Presto, and they now call it Presto SQL. And then you end up having two distros. So Presto DB, which is the one that Facebook continues to maintain and basically pushes to the direction they want. And Presto SQL, where most of the community is, the Presto founders are, and that is also where the Starburst data, so the company, the commercial company behind Presto, all of those are actually supporting this. So if you just compare Presto DB to Presto SQL commit log, you'll basically see the Presto SQL is really the most maintained and actually the active fork or distro. So I hope this answers the question, but you should know that there are some hosted versions of Presto, like Athena, for example, AWS Athena. It's actually Presto, but it's using an older version of Presto. And specifically from what we can tell from the docs, it's still Presto DB. All right. So just to sum it all up, Presto is really an open source project. It's still open source today. It's still being maintained today. It supports full ANSI SQL. So again, any type of software that writes SQL can just work out of the box with Presto. And one of the key concepts behind Presto is that separation of compute and storage. That is something that was traditionally talked about, but it wasn't really upheld in everywhere. That is, again, the reason why Presto was developed as a replacement to Hive. But Presto really does it. So Presto doesn't store data anywhere. It just connects to your data stores. If it's HDFS or S3 or SQL Server or Kafka or Elasticsearch in our case. So that basically means you don't need to do any ETL, and you can also support what we call query federation. So there are three main use cases to use Presto nowadays. The first one is the traditional, the reason why Presto was built, right? So executing SQL queries on cold storages, HDFS, S3, Google Cloud Storage, Azure Blob Storage, all of those, and make that efficient. So running a query on petabyte scale data and receiving results in sub-minute, in a couple of seconds, that is something that Presto really knows to do well. Even if it sounds surprising, it actually works really well. And that is the main reason why Presto was built in the first place. So many people use it for that. The other reason is, the other use case of Presto is what we call query federation, oftentimes referred to as data visualization, the ability to execute a single query, and that query can take data and query different data sources. So one query can query Elasticsearch, another query can query S3, another query can query Kafka, and I can have a single query even join data between all of those. So that we call that query federation. It is quite of a game changer, and I'll show you some use cases today. And it's really interesting, and a lot of people use it for that. And surprisingly enough, and many people also use Presto for ETLs, so for moving data around. So Presto can basically be used as the query layer for pretty much anything, and it wouldn't require moving data around. But sometimes people need to move data around, and Presto is actually, it turns out to be a very economic and very easy way of doing that. So that is Presto in a nutshell. About 15 minutes about what Presto is. Like I said, you can connect to Presto pretty much from everywhere because of the JDBC and ODBC drivers. The JDBC driver is open source. The ODBC driver does require a subscription license from the vendor, from Starburst. And like I said, in general, the architecture is completely separating storage from compute. So Presto is actually mostly worker nodes, a single coordinator node, and you can of course have a failover node for that. And you are, as the user, interacting with the coordinator only. The coordinator is going to basically manage the work that the workers are going to receive and do. And that's it. Both the coordinator and the worker nodes will connect to whatever data sources you have, and will try to push down as much work as possible to those data sources and receive the chunks of data, or hopefully filter data from those data sources. So again, just a compute engine, nothing more than that, but it works really, really well. Generally, again, the reasons to use Presto are for faster, easier access to data, especially if it's distributed across many types of data sources, and then also to manage access to those, right? So you want your data scientists to freely query HDFS and S3, but you don't want them to touch your production database, or you do want them to touch a read replica of the production database. I'll show you an example why soon, but you don't want them to be able to change anything if you give them access to a non-read replica, to the actual primary, and so on and so forth. So that is a scheme of how usually a usage of Presto in the real world looks like. Many teams of people using Presto as a data consumption layer, like I said, data virtualization layer, the query federation type of thing, and that Presto instance is going to basically answer requests from different people using different SLAs and different permissions, and that is again a very common use case of Presto. So where does Elasticsearch come into play? As you probably know, and also Rich mentioned that when he started, Elasticsearch can be used for several things, oftentimes. So I think 80, maybe even 90% of organizations that use Elasticsearch use it for for the analytics use case, so centralized logging, BI, sort of BI, real-time BI on top of your data sources. Not many actually use Elasticsearch for full text search, and the actual search use case, the vanilla search use case, but still, even if it's just 10%, it's still a lot of people. So Elasticsearch is quite a unique piece of software that you can find pretty much everywhere nowadays. And it satisfies a very unique set of requirements and purposes. Whether it's some sort of a search facade on top of your data stores, data warehouse, whatever, or maybe it's your actual golden truth or golden source of truth or for your data. But it is always going to be a hot layer. It could be a very hot layer to serve requests under in a subsecond always, or it can be some sort of a hot one cold, and the colder queries can take seconds, but it is always going to be some sort of a hot layer for serving data fast. Presto, on the other hand, is more oriented to the data warehouse, data lake use cases. It is there, it doesn't require much compute, and whenever you submit a query to that, it will just use all the compute it has available to satisfy the query. The more compute it has, the faster the query is going to run. So they're kind of complementing each other. If you look at the data platform as a one big space or one big challenge that you need to solve. And when we saw that, we figured, hey, we could build a connector that could do quite interesting things with it. Now, the open source Presto SQL doesn't have an Elasticsearch connector. However, it is not optimized in any way. It's just working, right? So if you submit a query to Elasticsearch from Presto, it will just run that query against Elasticsearch, but on big data sets, on real scales, it's not going to really work fast. It's not going to push down work to Elasticsearch so much. It's going to scan the data not as efficiently, and it has a lot of missing features. For example, it doesn't support geofields. It doesn't support writing into Elasticsearch, just reading from Elasticsearch. So it has a lot of missing features. So what we did, we went on and built our own connector for that. So the open source connector does support a lot of what I'm going to show you today. Some use cases are not supported by the open source one. So the first use case for making that connection and actually using such a connector is pretty much trivial, right? So the first use case would be take your existing BI tools, your existing query engines, your existing dashboarding tools, which are not Kibana, because if you are an Elastic user, you're probably using Kibana, but your, I guess, leadership team and analysts and risk assessment teams are not really going to use Kibana most of the time, because they also have their own data sources. And you can take tools like Power BI or ClickView and all of those, and just connect them directly to Elasticsearch. Now, Elasticsearch does expose this SQL plugin, but so it does accept SQL queries, but that's not part. I'm pretty sure, I may be wrong here, but it's not part of the basic free tiers. So some people don't have that. So a first use case of actually doing that would be to use Presto for that. So your BI tools can talk with Presto, and that could basically delegate those SQLs to Elasticsearch directly. So that's a pretty trivial use case. Another use case, and this is where it really starts getting interesting, is supporting your data warehouse kind of installations. So let's assume you do have, you are an Athena users. You are actually storing a lot of data on S3, on HDFS, and things like that. But you do want to expose search functionality like full text search, like GeoSearch, like supporting various Kibana features like the one we're seeing here. So the Kibana Maps application, which is a really nice application to use. And all of those are, of course, supporting very interactive way of interacting with the data. So you don't want to give that experience to your users, but you cannot really do that on your data warehouse because it's petabyte scales, and maybe you don't have the computes, maybe you don't want them to wait a second or a couple of seconds sometimes, and you do want that to be much more interactive in terms of milliseconds. So you can mirror some parts of your data into Elasticsearch and start supporting that. Now I'll make a short stop here and allow you to ask some questions. And while I do that, I'm going to share my screen and show you some demos of at least part of the things that we talked about. Okay, so this is my data grip. If you don't, you should see it. If you don't see it, just ping me on the chat. So this is my data grip. Data grip is just a SQL IDE. And as you can see here, just like I could have been connected to pretty much anything, MySQL and SQL Server and those SQL engines, I'm now connected to a Presto SQL instance running locally for me. And I can basically see all the indexes, and you're probably aware of those. So I can see all of those indexes, but they are now considered as tables. So this is a table, and within that, I can see all the columns, right? So like you can see, Presto now exposes my Elasticsearch indexes basically into as tables to this SQL query IDE. If I do show catalogs, I'm going to get the names of the catalogs that are available for me to query, and one of them is Elasticsearch. I specified to use the Elasticsearch default schema, and if I'll do show tables, again, I'll see those tables. So you can see those, let's call them system tables. And now I can also see the three demo indexes. You're probably aware of that. If you go to the Kibana homepage, to the Kibana main screen, you are being asked if you want to populate Elasticsearch and Kibana with sample data. So I did that just for the purposes of these demonstrations. And if I'm going to submit a simple select star from Kibana sample data flights, I'm going to execute that. I'm going to basically get the list of documents now, but instead of documents, they're now represented as rows, columns, as a table. And it's not surprising, but again, just to show you that. Now, it's full SQL, so I can do pretty much anything I want to do, like this query here, which can basically take the airport ID and do a count and do some so aggregations. And those aggregations are basically going to serve directly from Elasticsearch with one important difference. Elasticsearch does a lot to make sure that it is always satisfying queries in the lowest latency possible, right? So you're probably aware of that. Elasticsearch aims for being a very fast, very interactive query engine. And for that, it trades off performance and accuracy. So it will do a lot of time. It will do some sort of estimation and approximations and return that data to you as fast as possible, instead of taking its time and giving you a precise answer. And there's plenty of examples for that. So the group by is what we call terms aggregation in Elasticsearch does that, and several other ones. For example, one of those is the cardinality aggregation. And apparently this is exactly a very good example for that. So I'll switch to the DevTools UI in a second and I'll show you it there. But one important thing to understand is that by default, so Presto can push down things to Elasticsearch. It will definitely push down predicates for filtering data, but it will not always push down aggregations. And that default is actually a lot of times good for you, because Presto can actually work very well with Elasticsearch and get a lot of data from Elasticsearch in parallel for many workers and compute the exact data or the exact computation. And that's what's going on here. Presto, by default, will actually go and get all the documents from this index. If you specified a filter, it will filter those documents, and it will compute those aggregations on its own. It will not push it down by default. And a good way to see that happening is using a cardinality aggregation. As you probably know, cardinality uses an approximation algorithm. So if I'm running the select count distinct on flight num, some field, some high cardinality field on the sample index, I'm going to get these values, so 1359. Let's switch for a second to DevTools. So again, I'm on the DevTools. You're probably very familiar with that. I'm seeing the same indices as you've seen on DataGrip, and I have this sample data flights index. If we just do some simple search, you're going to just see all the documents. We have more than 10,000 documents. Again, in starting version 7, you can only see an approximation of number of documents. It's another optimization in the route to being faster in the expense of accuracy. But now let's run the cardinality aggregation on the same field that we've seen before. And if you run that, you'll get this number. So less than 13,000. Now that's not definitely not the number we've seen. We've seen 13,059. But so the cardinality aggregation allows you to fine tune it a bit and get a higher precision threshold. So the maximum you can put here is 40,000. And if I execute that now, I'm getting 13,000 as the cardinality of that field. Now, I'm still off by 1, right? We are in disagreement between the cardinality aggregation of Elasticsearch and what Presto tells us. And I can tell you that the real number in our case is what Presto presents. And again, because Presto basically pulls the data and computes it itself, it is just accurate. And as long as you have enough compute resources, you should be able to complete that in a very fair time. So again, if you need very low latency queries, you should probably query Elasticsearch directly or push down those aggregations and let Elasticsearch deal with them. But if you're actually looking for being more precise, then running those queries through Presto and letting Presto do the computation is the direction. So just to give you an idea again of the differences and what Elasticsearch and specifically Presto bring to the table.
We do have a question.
Yep.
There's a question in the chat.
Yeah, so BK asks, does your data source artifacts need to be stored in a certain way? Assume you have 1 million artifacts, how does Presto selectively load the current artifacts to get SQL rows? So I assume by artifacts you are referring to documents in an index, and no, it doesn't need to assume anything. So in other data stores, we may actually need to do some interesting or non-standard things like storing data on S3 will actually require you to store data in files, specific files. But when using Elasticsearch, you just use Elasticsearch as is. You don't store it in a certain way. You're just storing documents in an index. Using S3 HDFS, you're not going to want to use, okay, on AWS S3, you're not going to use CSV or JSON files. You're going to use ORC, Parquet, other format types to make sure you are fully optimized. But again, on Elasticsearch, the integration is completely smooth. Just the connector just does all the magic. Let me go back to the slides. So that is going to show you an idea again of how queries against Elasticsearch through Presto are going to look like. I'm going to show you in a second how would querying your data warehouse or data lake is going to look like. But before that, I want to touch on the query federation approach. So a lot of times when you use Elasticsearch, you're going to have to denormalize data, right? There is no way for you to keep two indices, one index for users and one index for some other business data, and merge them together. And a lot of times, actually, those types of OLTP kind of data is going to be with completely different database, right? For example, you're going to have a MySQL production database that is used for OLTP data that is going to constantly be updated. And Elasticsearch is more of an OLAP kind of technology. So it's going to have hopefully append-only data, but even if it's data that it's still changing, it's meant for the analytics purposes more than being some sort of an OLTP data store. So what Presto allows you to do is execute a single query, similar to what you're seeing here, that will allow you to join data between those two data sources. You're going to execute a single query that is going to fetch data from Elasticsearch and then substitute the user name, for example, by using substituting the user ID with the username, or filtering based on the username, and that query is going to run against the OLTP data store to filter data that is coming from Elasticsearch. So that's a very interesting use case, right? Instead of going through the entire deal of how I should denormalize my data in Elasticsearch and what it should look like, and things like that, you can now get a chance to just simply query both at the same time and let Presto do the magic. Of course, it is never going to be as fast as just denormalizing everything and letting Elasticsearch do it all. But sometimes in some use cases, we can actually take a great leverage of that. Another thing that this approach could solve is another use case. And again, this is just a pseudo SQL that shows it. But of course, if you're using Elasticsearch, you probably know that you should be using Elasticsearch with flat documents. Nested documents and parent-child feature, or join field, the way it's called now, are supported, but are not really recommended. Definitely not for production usage of very large clusters. So the whole traditional relational mindset doesn't really apply and shouldn't really apply to any usage of Elasticsearch. If you have a relational mindset, a relational data model, either translate it to a document-oriented data model, which takes care of things like aggregate roots and things like that, but not every model can fit there, or don't use Elasticsearch. Now, sometimes, again, in my 8+ years career working with Elasticsearch, I've seen things that could justify doing some sorts of joins, and those joins traditionally have been made applicatively from the application side, and that would have resulted with two-phase queries and scrolls and those kind of things. So now Presto can do it for you. You can just submit a simple select statement. That select can do a join, a set of join, and what have you, and everything is just going to work. And I'll show you an example for that in just a second. We'll jump. You know what? Let's jump now. Let me share the console again. All right, so I want to show you actually two things now. So one of the use cases I talked about, I showed you how you can take data from a data warehouse and push it into Elasticsearch. So if we look at the Kibana flights index again, that data looks like this. And now what I can do, I can execute a query like I did before and do some aggregation. So, sorry. I can just do a count and a sum. Schema must be specified, of course. So Elasticsearch default. All right, so I can just do basically a select group by, which in Elasticsearch terms would be to do a terms aggregation on this field and do a count star that you get by default in the terms aggregation, and then do another sum aggregation, metric aggregation under each bucket, right? So that is what it would have been translated to in Elasticsearch. Now I'm taking this data set, and what I can do, I can push it into Elasticsearch, right? So it tells me that that index does not exist. Let me jump to DevTools. I can just put this index from scratch, and jumping back to the console, I can now just run this, and it's going to work. And now let's do select star from this index, and you're basically going to see the result of this query now persisted as a, let's call this a temporary table, or however you want to call this, but that's basically an index that was created by Presto, and this select statement used as the data source for that table. Now think about it. Now I did it from Elasticsearch to Elasticsearch, but if I would have done insert into Elasticsearch my view and did select, and that select went to S3 to do some queries there, and that insert into would have created an index from a select statement that I picked data from my data warehouse, I get a lot of data in Elasticsearch in a way that it is just native to Elasticsearch, and I can just use Kibana on top of, you know, a portion of the data from the data warehouse. And again, you saw it took just under a second to do that. It will take more if you do this in large scales, but it can definitely work, and we've done that several times now, and with a huge success. We usually do this for data that needs to be browsed in the Kibana Maps applications or in dashboards, in the Kibana dashboards with the special things that it can support, or full text search and things like that. And I talked about joins, and like I said, the Elasticsearch doesn't really allow you to do those kind of things. And the only way that you can do sort of let's call this MapReduce, so deeper kind of computations with Elasticsearch, because you cannot do joins and because you cannot do set of joins, the only thing you can do is use the feature that's called transforms, right? So an internal ETL with Elasticsearch that takes your data and allows you to do things with it, and including also some sort of a self-join functionality. So what I'm going to show you now is how you can do that with Presto without doing any ETL, essentially. So what you see here is a query that basically takes that flights data. Let's look at that for a second. So this is looking at test. Let's look at the actual data store. Okay, so you can see there's a lot of data. So mock data, average ticket price, and carrier, destination, and we also have distance, kilometers, and we have the timestamp when the flight was taking off, and there is a duration somewhere around here. There is some sort of a duration and a delay. So what we can do, we can now take the entire data set and add another column to it, or columns, right? So I'm just adding columns or adding fields. And if I'm going to run this, it's just not going to work. I'm going to get additional timestamp, which now talks about the landing time, if the data was real. But I just added another column, and that's a view, right? I can just execute that query and execute queries on top of it, or I can go ahead and create a view out of it. So there is a connector in Presto it's called the memory, and it allows you to do interesting things. And basically allow you to save temporary views. I could have just wrote that back to Elasticsearch, but just for demonstration purposes, I don't need one second. Okay, and I ran this, and now I can do a select on top of that. So okay, now I can do a select. I can now select the origin the number of next flights and and distinct count of flight numbers. So how many flights departed within 3 hours of the flight that just landed in the same airport, and it just works. So now I can get a chance to do joins between indexes or joins or self joins and answer much more sophisticated questions and not requiring to do any ETLs whatsoever. So, and again, what Presto is going to do here is try to push down as much as possible to Elasticsearch, but then get all the data from Elasticsearch and do the computation on its own. You do have to know SQL quite well. That era hasn't ended yet, but if you do, you can do quite of interesting things with it. So this is the last slide, but one of the interesting things with Presto is that people ended up doing a lot of data moving around, so ETLs, data ingestions, and you can also use Presto for that. So if you have Kafka, Kinesis, a lot of data ingestion pipelines kind of technologies, you can use Presto to write them into Elasticsearch as they go in. So Presto can also act as some sort of replacement, if you will, or a single place for querying and also ingesting data into Elastic. So that's what I had for you today. If you're interested in learning more, there is a blog post showing some of what I've showed here, and I link to it over here. This is the blog post of on our blog, or you can just reach out to us. There's more details about us here. You can find us on Twitter, email, or the internet in general. And if you have any questions, I'll be happy to answer them now. I hope you enjoyed. There is no beers and pizza, but it's as good as it gets, I guess. And hope everyone stays healthy. And again, I'm here to answer any questions.
Does anyone have any questions? You can unmute yourself if you have anything else to ask. Yep. Instead of just typing it. All right. Edmar, I really liked it. This was a really nice presentation. Definitely something I have not seen before. And tying it all together, I thought it was also cool that you're using the sample data that comes right from and you can load into Kibana. So that was pretty nice too. But definitely, I like the way that you took it through and walked us through this. There's opportunities you can do with Presto.
Thank you very much.
Let's see, is there?
So I pasted the link to the blog post that we published a couple of months ago, and you're happy to look at it. It basically summarizes what I showed you here without the demo. I didn't have any demo fails. That's nice.
Yeah. All right. Any questions from any of the RSVPs? All right, I guess that's it. Okay, thanks everyone for joining. Phoebe did put a link in there for our survey. We'd love to hear the feedback. I think it's definitely a different format, a little more challenging than being in person and kind of getting that, the in-person discussions and so on. But this is a really nice presentation. I really enjoyed it. The Elastic Stack, at the end of the day, you have a ton of things to talk about. If you're interested in anything in the future you want to present, definitely reach out to me. Love to hear it. And the next meetup is October 21st, I believe. And we'll be sending out an announcement as soon as we can.
Alrighty, I think if that is it, if there's no more questions, I'll go ahead and close this out, and you can all have a wonderful evening or morning, as the case may be. Thanks, everyone. Thank you so much, Rich.
Thanks, everyone. All right, bye.
Bye.
Bye.